Okay, so in most real-world problems, we write, when we see the square root of a negative number, we write undefined, because the square root of a negative number is not defined in the real number system. But there's a bigger number system that encompasses the real number system called the complex number system. And in the complex number system, we're able to take the square root of negative numbers. So let's look at how we do some computations in the complex number system. And it allows us to solve bigger problems when we're able to take the square root of the negative number. Okay, so we're going to define the square root of -1 as I, and it's little I, lowercase I. So if accidentally in here it's made any of the i's uppercase, just realize that's just Word doing that. It should be a lowercase I. If we square I, we get -1. Now, that's kind of counterintuitive to what we learned in the real number system. When we square something in the real number system, it's always positive. But I, since the square root of -1 is equal to I, when we square it, we just get what's in that radical come out as -1. And I to the third is equal to -I. I to the fourth is equal to 1. And it's good to have these available to remember these four, and we'll see why in just a few minutes. Okay, but let's go on to simplifying some square roots that have negatives in them. So we know the square root of 16. We know that's 4. Since we know the square root of -1 is I, let's think of it as this problem. We're going to have the square root of 16. I won't do this for every problem, but just giving you an idea of what's going on. And then we're going to multiply that times the square root of -1. So I can copy that. And that's really the same thing as the square root of -16. Now, we said up here that the square root of -1 is I, so we're going to rewrite this part as I, and we know the square root of 16 is 4. So this is 4I. Now, there's no reason to write out these steps every time. We can kind of look at this and do this without doing that. So we know the square root of 49, that's 7. And then we write, for the square root of -1, we write I. So that's 7I. Same thing with the square root of -10, or -100. We know the square root of 100 is 10. And then our square root of the negative part is going to be I. And I need an equal sign. So we get 10I. Now, what do we do if it's not a perfect square root? Well, let's break this one up a little bit. Let's remember from back in intermediate algebra how we broke down something like the square root of 24. So I'm going to break down the inside of my radical, and I'll just go ahead and insert another radical here. We know the -1 part is in there. But let's think of multiples of 24. And we want, within those multiples of 24, we want a perfect square. So I could say 2 and 12, but 2 and 12, neither one of them are perfect squares. However, 4 times 6 does yield me a perfect square with the 4. And if we can find a bigger perfect square, we want to use it. This one doesn't have a bigger perfect square, but we always want to use the biggest perfect square we can find when we write this out. So I can take the square root of 4, that is 2. I can rewrite my square root of -1 as I. And then the square root of 6 we do not know. It's going to stay inside of that square root symbol as is. So I'm just going to leave it right inside the square root, just like that. And there's our broken down square root of -24. So let's do the same thing with -75. So if we break up -75, it's -1. And if we start thinking about something that multiplies that gives me a perfect square, well, we have 25 times 3 that gives me 75. All right, so now let's work that out. Well, we know the 25, its square root is 5. we're going to write I for the -1 square root. And then the 3 is going to be stuck underneath that radical still. So we get 5i square root of 3. All right, so let's break up the square root of -500 in a similar fashion. And you know, if you can do these in your head, you don't have to write out the steps here necessarily. And many of you probably can. I'll show it to those of you who need it. So 500 is really 100 times 5. And 100 is a nice perfect square root. So, oops. All right, so we know the square root of 100 is 10. We'll go ahead and put an I for our square root of -1. And then the square root of 5 is going to stay underneath that radical. So we end up getting 10i square root of 5. All right, now, remember a moment ago I said it helps to know these and to write them down? All right, so let's take a look at this. We're going to simplify I to the 5th, and we're going to simplify it to one of these 4. So if we think about, these are actually cyclic. So we go through these 4, and then 5 goes back to here, and then 6, 7, 8, and so on. 9, 10, 11, 12. All right, so I to the 5th will take us right back to here. Notice I to the 5th is the square root of -1, or really, we'll just reduce it to I. All right, now let's say it's bigger, like I to the 27th. Since these are in multiples of 4, let's just think what would be the nearest multiple of 4 to 27. It would be 24. And 24 is right here. So we'll go 25, 26, 27. We're going to get -I for this one. All right, now 59. Again, let's think. Nearest multiple of 4 to 59. Let's see, it's going to be 56, I believe. Yes, 56. All right, so 56 is the nearest one. So we're at 56 right here. So we'll go 57, 58, 59. That 2 is -I. All right, let me scroll down. Now, I to the 64th is a multiple of 4. And since it is a multiple of 4, that puts us right here. This answer is going to be 1. Okay, so we know how to rewrite those in terms of those first 4 things. Now let's look at this. We want to multiply out 2i plus 3 times 4i minus 5. And we're going to FOIL it in the same way we did if we had 2x plus 3 and 4x minus 5. So let's FOIL this out, and then we'll simplify it even further. So 2i times 4i is going to be 8i squared. All right, and now let's take our outside 2i times -5. We'll make it be -10i. And then our inside 3 times 4i is going to be 12i. Go back here, it just wants to capitalize everything. All right, and then 3 times -5 for our last will be -15. Okay, now normally our last thing would be to just add like terms here in the middle, but we have to keep in mind that I squared is actually -1. So if we think of that, we really have 8 times -1 right there, minus the 10i, plus the 12i, minus 15. So really I've got -8. I'll go ahead and add the -10i and the 12i just so I don't have to keep rewriting both of them. It gives me 2i. But I still have to add my -8 to my -15. We end up getting 2i minus 23. Now, most complex numbers are going to be in this form where you have what we call our imaginary part that contains the I, and then a real number part out to the side. All right, so let's take a look at the next one. Again, let's FOIL it out. So 5i times 5i is 25i squared. Outside 5i times 2 will be 10i. Inside negative 2 times 5i will be negative 10i. And then last, negative 2 times 2 will be negative 4. Now again, we've got that I squared. Let's replace it with a negative 1. Notice 10i and negative 10i will cancel one another. So we end up with negative 25 minus 4. We get a real number out of the multiplication there. We get negative 29. All right, now the last thing we're going to do here is simplify it by factoring. So the first thing we need to do is we've got that square root of negative 4. We're going to rewrite it the way we did the square roots that we had previously. So we know the square root of 4 is 2, and we know the square root of negative 1 is I, so this will be 2I. So I will rewrite it as 14 plus 2I. Now let's factor out a greatest common factor. Let's notice that 2 goes into both of these numbers. So if I take out a 2, 2 out of 14 will be 7. If I take the 2 away from the I, I'll just have I. And notice if I were to multiply it back, we'd be back here again. Alright, so let's do the same thing with this next one. Square root of 18, really, we can rewrite that as negative 1 times 9 times 2. And then let's break that down. Our negative 1's going to be, square root of negative 1's going to be I. Our 9 square root will be 3, so we'll have 3i, and then the 2 is going to stay in the radical. Now, let's notice if we look at these, don't look inside the radical. What goes into 18 and 3? We have a 3 that we can factor out. So if we factor out a 3, 3 into 18 leaves 6, and if we factor out a 3 in the second portion, we'll have the I and the square root of 2. And I'll put a parenthesis there on the other side. All right, now let's do this to the last one. Again, let's break down the square root of negative 200 first. So I'll have negative 1 times 100 times 2. We know the square root of negative 1 is I. We know the square root of 100 is 10. So we have 10i, and then the square root of 2 will stay underneath. Now, if we look at factoring, we can take a 10 out of both of these expressions. So let's take out a 10. 10 will go into itself one time. And then in our second part, we can think of the I as being there, and the square root of 2 will still be there. And now we should have all of the operations necessary to deal with our complex numbers.